Hello everyone. Sorry about the changes in time. I'm convocating today, so I have to do this to rush with this stuff. I'm supposed to be in school by 9, but then that's not going to be the case. I have to finish this class with you guys, so I'll go a little bit late. Um so let's go right into it. Let's rush it. I hope that in the course of doing your assignments you've been able to, uh, you've been able to read up the documentations and watch the videos. Today we'll be learning recursion. Today will be a recursion class. And what then is recursion? The recursions feel like a function calling itself so many times. It's just like a loop, but a more advanced pattern of having a loop. I'm sure that you've seen the documentations and materials and you understand. All you need is for me to help you start out, do a few, so you get like a hang of it and explain it to you. So that's what a recursion feels like. It's like a function that calls itself continuously like a loop until it meets a condition, you know, that breaks the function from calling itself. Okay, so we are going to go straight to our assignments. Like I said, the assignments are built to give you more insight on this stuff. If you are doing the assignments, you get better at this. You know, um, I'll have to share my screen today. I'm not planning on wasting too much time. Although we are learning something big today, but precautions are big. They are really powerful. It's a really powerful tool. The last time I built a program that for a company I work, I built a program that monitors our competitors and all that. It was a recursive program. It kept doing checking stuff, calling it a function so many times because there were like a lot of information to be gathered. It was a small robot, and the core of its functionality was a recursive function call. So recursions are really, really handy. Like that robot was solving the job of 1,000 persons. Trust me, if you know how to do recursions very well to make your work easier, especially repetitive tasks, you know. Anyways, I'm going to go right into it and show you solve a few of your assignment questions, just so you understand how to go about this recursion. Okay. Um, let's dive right into it. I want to share my screen. Share. All right. Yeah. So this is it. This is a recursion question. It says at the end of this class, you should know what recursion is, how to implement a recursion, which is my primary focus of coming online to ensure that you guys know how to implement a recursion, a recursive function, and in what situations do you need to do a recursion, and in what situation shouldn't you implement a recursion. Okay, okay. There are some situations where you don't need it. You could just use a loop and stuff like that. All of these questions should be answered in your documentation. I hope that you've gone through them. If you've not, please do that. Let's go further. What are they saying? What are they saying? That we should be compiling stuff. Yeah, and here they say we should use underscore put char. We built this function some time ago. We can build it again. I think let's just do that again just to refresh your memory. Okay, so the first task says write a function that prints a string followed by a new line. Okay, so we are writing a function that prints a string and it prints a new line at the end. That's the first task. But before we do this, we are using puts for the printing, right? So we'll have to go create the puts function first before we, yeah, we'll have to go create the puts function first before we go further. All right, so to do that, Let me. Where's this stuff? Okay. Sorry, I have been a little bit distracted. Let's see. You do with your phone. I beg, do the data fast. Do the data fast. Okay. Sorry, I'm running out of data. I have to do something about that. Okay. Yeah. So a few things. I just had to solve the data issues, so it does not affect the class. All right. So done, right? All right. Rushing off. Okay. Voila. So we have data now. We can we can move forward. Um. All right. So the first question we are having here is saying we should write a function that prints a string followed by a new line. We are going to use the puts function, and we are going to print the string as in an array. How they print an array, each character of an array, because we want to use a recursive pattern of printing this stuff. So for each okay, it has see how the recursion is being called. Is a function. It's saying puts recursion, and it's saying put the recursion, something like that. And yeah, it's going to print put the recursion on the screen as uh yeah. So what we are trying to do is to build a function that for the first instance of calling itself, it prints p. The second time it calls itself, it prints u. It calls itself, it prints t, until it gets to the end of the uh till it gets to the end of the string that we are printing. Okay, and then when it gets to the end, what the most important thing about recursion is when you get to the end of the string, when you get to the end of the task, the program, you want the function to know. You want, you know, you want to have an output that makes the function to stop running. Else, you can keep printing and printing till you run out of memory. That's the delicate part of recursions. So what we do is, first things first, like I said, we take this up, clear, and let's move cd into wm tests, and let's make a directory here and call this recursion. We have to cd into it, clear this, and then first things first is let's make our puts statement where we will uh, be underscore putcha. Let's call it underscore putcha. That's the word. That's the name we've always called it. That put a character. That's what that means. Okay. And here, first thing we want to do is to include the right, and the right is in the standard library unistd.h first before we go out. Yeah. So I always tell you guys to put comments here, but I'm rushing, so I have to type fast. Okay. Yeah. So here, this should take in a character. We usually used to, yeah, you have to define the type first before giving it. So we are returning. Let's return what we are writing. Return. In our return statement, we want to write. We've brought in the standard library for writing. So what do we want to do? We want to write the uh, address of C, and we want to tell it to allocate 1 byte to each character. Characters are byte. Characters are 1 byte long in programming. So that's that for that. I think that should work. That should work. The next thing we want to do is we want to build the function that the question requires us to build. Yes, that question. Yeah, so the question says we are building this function puts underscore puts underscore recursion. And what's the name of the file? Let's copy this prototype. Okay. And remember, I said all the prototypes should be defined in a main.h file. Okay, so we have to make a main.h file, main.h file. And remember what I said in our last class. If you've seen the last class, I said if not defined, we want to, if file underscore main is not defined, we want to uh, define small letter. We want to define file underscore main, and then at the end of it, we want to end if. We want to end the if statement. Now, the next thing that's very important is our prototype. Our putcha, we've not put it. So we'll put our putcha prototype here first. It took in a character C. And then the next thing is we need to put in the one we just copied. Yeah. Okay. So that's that. It's taking in a character S. So we'll go create, what's the name of the file? The name of the file is, where did they write that in the question? Name of the file. Yeah. The name of the file is 0-puts underscore recursion. Yeah, that's the file we are creating, 0-puts underscore recursion. And our main, first of all, what is our main.c file doing? It is just calling the function. There's no other thing. So everything that we have to do in this particular this thing is to be done in the 0-puts underscore recursion file. All right. So let me paste the main.c file first of all. Cat 0-main.c. Let's do this, Control D. Yeah, and then let's create the puts. All right, so we continue. Yeah, so we just copied this and pasted it. The next thing we want to do is to create the 0-puts underscore recursion file, and that's we doing vi. Let's ls to see that we are on the same page. So we vi 0-puts underscore recursion. Okay, dot c. Okay, so what are we doing here in this file? We want to build a function. And okay, first of all, let's call in our main.c file. Let's include our main.c file, main.h files rather, main.h, and we have like a small bug here. Okay, yeah. So next thing we want to do is call our function void underscore puts underscore recursion, void underscore puts underscore recursion, and it's taking in a character pointing to s. Yeah, I remember very well. Okay, so what are we doing here in this file? We want to, our function has to keep calling itself until a condition is met that makes this function not to be able to call itself anymore. In essence, inside this function, we are going to call this particular function. That's how recursion works. Okay, so first of all, we want to print a string. It's a string. We want to print every character of the string till it gets to the end. And then when it gets to the end, we don't want it printing anymore. So what do we do actually? I think what we should do is we should first of all call the condition that breaks the recursion. That's it. So we want to say if it is at the last, if the current if the current value of s, if the current position of s is, if it is equal to the last term, remember double equals, if it is double equals is the, what do they call it, is an equator, not an assignment. Is an equator, not an assignment. So if the last what do they call it here, if the current value of s index, if the current index of x is equal to the n term of an array, that's what this is. I've taught you guys about this. Is equal to the n term of an array, then it should break out the loop. It should break, it should return, it should have a return value. right? So we are going to say if that's okay, first of all, it should print a new line. I think that's what the question said. The question says the question says write a function that prints a string followed by a new line. So at the end of the string, it should print a new line. So at this point, we know that this is the end. We want to print a new line first before we return. Remember, the return statement is the end of a function. So that would end our recursion, So basically what we should do is we should print, let's use putchar to print. We should print. And what are we printing? We want to print a new line, right? We want to print a new line, and then we want to do our return right here. This is the end, so we want to return right here. That ends the function. Now we've tackled the condition that ends the function. Remember, the last item in every array is the end term, the end of an array, and this is how it's written in C programming. So if we look through this array and we finally find this in the array, we should return. We should print a new line and run a return statement. Yeah. So having said that, what we want to do now is uh we want to keep printing the value of s. We want to keep printing the value of s. I have not told you about unwinding in we are printing the value of s before we call the function each time to increase the value. It's not put char this time, it's underscore puts. It's underscore puts. We made an error at the top here. This is supposed to be puts at the top as well. So thank God we've not run and gotten an error. Okay. S plus 1. Okay. So this is an error. I just saw this. Okay. So this is pretty much our function. What this does is it keeps printing the current value of s and keeps calling the value of s plus 1, which is the next character in s. So each time it keeps calling this function that prints the value of s, and it keeps increasing the value of x to the next character in s. It does that till s gets to the last term in the array. So when s gets to the last term in the array, it ends the function. So the function stops calling itself. That's what it is. That's what recursion feels like. Okay, I'll use another example. I think the next question would show us what unwinding feels like when the putchar value is after the recursive call. I'll show you what unwinding feels like. All right. Having that being said and done, I think it's high time we save this and let's let's see if we have any errors. I think okay, all files are there. All the files are there. Let's see if we have any errors. Uh-huh. Uh-huh. Okay. So it's complaining. What's it complaining about? Oh, It's complaining that we are making a comparison between a pointer and an integer. It's complaining. Why is it saying this as that, as an integer? Why? That's the last term of an array. Okay, so vi, let's go check what's wrong. Zero dash puts, right? What's it complaining about? This is supposed to be a character. I don't want this to, okay, let's see. Oh, okay, so that's that. So I had to change it was seeing this value as an integer, so I had to change it to smaller quotes to make it know that it's a string. C is very unforgiving, you know, very, very unforgiving. Each small, very minor error you make, C is going to point it out for you and tell you, hey, there's a problem. I don't, you know, I don't understand this. You need to. That's why we are using C to learn. It's going to be much easier when we start doing Python, using Python, you know. But for now, we have to be using C because C will teach you all the concepts. It will, if you overcome frustration in debugging when writing C programming language, then no other language can frustrate you anymore, you know. Anyways, let's go further. I think we should, you know, test this stuff. All right, so it prints the correct thing. It keeps calling itself and it prints puts with recursion, which the main.c file has on it here. That was the required output. The main.c file already printed puts with recursion. So it puts characters in on the screen with using recursion. Okay, so that was correct. Let me open this stuff. Yeah, so this is it. This is what we did. We built a function here, and then inside this function, the first thing we wanted to do was to ensure that our function will have a call. It would have the first thing we wanted to do was to ensure that our function will have what do they call this? Uh, a condition. Would have a condition that anytime this condition is met, the function will break out. It's going to return something. It's going to run the return statement and it would end the program. That's the very first and most important thing when handling recursion. So your function does not keep running and running and running and burning off your memory, you know. Very important. That's the first thing I thought about. That's the reason why this is your first question, to ensure that you understand this part of the code. Before we even start the recursive call, the function kept calling itself and incrementing, kept calling itself and incrementing the value of s. And for each time it kept indexing the value of x, the function sees put char s, it sees the current index of s to print it to the screen till it gets to the end of s. At the end of the array s, it sees this, and then it runs the return statement. After printing a new line, it runs the return statement. And that's why we have this correctly. We have a new line here. That's why this is starting on a new line, you know. So that's for this first question. I expect you to go read your materials and, you know, understand uh, the knowledge that we are trying to pass to you right here and right now. Yeah. So the next question we want to solve is the one where I used to teach you how unwinding works in recursion. These are the three things that you need to know. One, you need to know that the function is calling itself. Two, you need to know that the function needs to hit a condition that will break out of the function. And then three, you need to know what unwinding is. The first time we printed something before calling the function in the function. Now we are going to be printing something after calling the function in the function. Yeah, so question one says, write a function that prints a string in reverse order. We should write a function. Our function should print a string in reverse order. In essence, you print from the back to the front. And that brings us to the concept of unwinding in recursions. Each time you build a recursive function, while the uh, function is still calling itself, you know, it prints stuff from the beginning to the end. But then at the end of the function call, after the recursive function calls, if you print anything, it will start counting back from the back of all the outputs that it has printed to the front. In fact, I mentioned the program that I built one time, and I told you the backbone of the program was a recursive function call. I was not printing anything when the program starts running. I wait till the program finish running all the outputs, and then when the program is unwinding is when I now start looking at each of the output and using the output to do whatever I want to do, you know. Now, this is why recursions, this is the difference between a recursive function and a regular loop. Regular loops don't unwind, okay? So we need the recursive function to, you know, do a task, carry out a task, print out outputs for each instance of, you know, each output for each instance of the function call. And then at the point where we are unwinding, we already have all the outputs. So we can now make decision and return values based on the output from the end of the program to the very beginning. You know, this is why recursions are a little bit different and advanced from regular loops that we use. Else, somebody would have asked me at the beginning of this class, why not just use a loop if you know you want to print? You've been printing with loops since. You've been running through arrays with loops since the beginning of the training. Now I have answered you. This is why I don't just use a loop. This is why I want to do what I'm doing the way I'm doing it. All right. Where's that stuff? The second question. It's almost getting to 9 o'clock, and I'm sure that by the time I do like two or three of this stuff, I have shown you the concept and how to build recursions. So you go complete your assignments by yourself. Remember, the reason I always come online is not to help you do your assignment. That's not how to teach you. I always come online to show you how to do your assignment. You know, how to think, how to structure your. I believe that a lot of us here are beginners. So I'm showing you how to set up your files, how to think when tackling the programs and all that. You have to go struggle with logical reasoning to solve these technical problems that you have to solve. All right, so this time around, we want to print in reverse order, and it's still the same kind of function. Okay, these are prototype this time. We have to go dump it in our main.h file. Yeah, so we've done that. What's the name of the file, the new file we have to create? The name of the new file is this one dash print reverse recursion. Let's just copy this stuff. And let's go make it vi one that prints reverse recursion dot c, right? It has to have a dot c at the end. Yeah, so that's what it is. First things first, we include our files. We are not using standard libraries here. So first things first, we include our main.h file. And next thing we have to do is the uh, function. We start building the function. It was return void, and it was no, not put. It was print reverse recursion rev underscore recursion, taking in another s character, right? And the character is supposed to be a pointer. Taking in another s character, right? Okay. So if remember what I told you guys about breaking out of the function being our first priority. This time around, we want to print in reverse order, you know. This time around, we want to print in reverse order. So what are we doing? We want to allow the function get to the end of the string to call itself to the end. And then when it is unwinding, we want to now start printing. So what do we do? Let's go print this to the end. Let's call ourselves, we are print underscore rev underscore recursion. This is what a recursion feels like. A recursion is a function calling itself. I've said it over and over. So we want s to keep incrementing while it keeps calling itself. Now, as s keeps incrementing, the value of s here keeps changing to the next index of x as a character, which we know that s is a string here. So the next thing we want to do here is to put char to print. Remember, I told you about, I want to show you about unwinding, what unwinding feels like. Now, this is us calling the function the exact same way that we did to print a string from beginning to end. But remember, last time our putchar function was at the top, right? This was at the top here. We don't want to return. We want it to unwind. We want this recursive function to actually unwind. That's why we are not returning here. Remember what I told you about returning? Last time, we wanted to get to the end and end the program without having it unwind. But this time around, we want it to get to the end of the program and we want it to unwind back to the beginning, you know? So as it's unwinding from the back, like I told you, to the beginning, we want to be printing something. We want to be printing every index of x. Okay, so let's save this stuff. Let's save this. I think there's an error here. Yeah. So let's save this and let's see. ls. We have this. We've not brought in the main.c file that calls the function. So let's go do that. The main.c file here is just calling the function and it's returning for us. Returning 0. Okay. And what it's going to print is quoting worker, but this time around it's going to start from the back to the front. Okay, so let's go paste the main.c file. Cat one dash main dot c, and yeah, okay. And next thing is to do gcc on this. gcc one dash main dot c one dash print, and uh, what's the next thing? We are not using puts here, are we? We are not. So dash o dash one dash print. Let's remove the c. Okay. So yeah, it's complaining that it's not seeing put chart. So we are using puts. Where are we using puts? Oh, we use puts in our. Okay, so let's go update this to add puts. You know, underscore puts. All right. So I'm not sure. It's not complaining anymore. That's to say that we are correct. I forgot that we use puts to print in our statements. I was looking at this place when I said we are not using puts. All right. So that's that for that. We have everything here. Compilation did not throw an error. That's to say that we are correct. And yeah, what do? We run it, and as you can see, it prints from the behind to the front. This is me illustrating what unwinding feels like. The first time we had our recursive call before, uh we had our function printing before our recursive call, and that made us to print from the beginning to the end, because as it was going through the loop, it was going through the loop from the first index, which is point 0, to the highest index. And then now that we are printing after the recursive call, it's now checking from the back to the front. That's why it printed this quoting what rec law, something like that. He printed it from the back to the front. I've forgotten what this is, but whatever it is, he printed from the back to the front. So this is me illustrating unwinding, and that's pretty much all that there is to know about recursion. This is why recursions are different from the regular loops. Regular loops don't unwind. That's one. Two, regular loops, uh, they call like a condition, not a function. So this time around, you can call an entire function, and you know what functions are? Functions are, they are like actions. You can instruct the computer to do a whole lot while creating the output, and after creating the output, you know, with the output, you could still do a whole lot during the unwinding, you know. So that's why recursions are like really, really, really powerful. Like they are really powerful. It's like a very huge tool to understand, to master. Let's cut. Let me clear my screen first and cut zero dash. What was the first one? Zero, was it rev something? No, let's ls first. So we have to cut zero dash puts dot c, and we have to cut one dash print dot c. Yeah. So this is what I wanted to show you. I wanted to show you why recursions are really, really, really handy in programming. When we put the put char before the recursive function call, it kept calling itself from the beginning to the end. This time around, we are putting the put char at the end after the recursive function call, and it kept calling with the unwinding procedure. As it was going back from the behind to the top, it kept calling. This is one difference between regular loops and recursions. Recursive functions are really powerful. Now imagine that we are not just printing we are not just printing something to the screen here. Just imagine we are not only printing something to the screen. This to tell you we could do something. you know we could do something here that throws an output, and then we could still use the output here after the recursive call. We could still use outputs to do further tasks. This is a function does tasks. you know we could still use the output to do things, set things and all that. This is just how recursion works. We are going to use it. You guys might use it when you're building robots, robots and other things when you start writing Python and other programming languages. But this is just how I teach you the concept of what recursion is, what it does, and how powerful it is. So people that have open minds watching this class, already I'm sure that your minds are supposed to be working right now. You are seeing the possibilities, endless possibilities you could actualize using recursions. You know, here they say we should write a function. Somebody is telling me congratulations, sir, on WhatsApp. Somebody that is supposed to be in class here on the live stream is texting me on WhatsApp. Well, this class is, that's why I put the class on YouTube, so it's easier. I don't want to be uploading this thing. It's easier for you people to watch it anytime you feel comfortable. You know, YouTube is a lifesaver for us on this training. All right. Here it says write a function that returns the length of a string. That we should write a function. Our function should return the length of a string. This is a very simple recursion, you know, very simple one. All that it's supposed to do is, return the total number of, increments that it does in a string, you know. It's so simple. I don't know if I should even do this one for you or if I should go to the next one, because this one I see is factorial, and this factorial is a little bit complicated. I'd love to do this for you. Okay, let's see. I have a bit of time. I think I should just rush through these two before I leave you guys. Like I said, I have my convocation to be at. Well, I love you guys. You guys are my my people, my very own people. So I can't just leave you guys without teaching you people something today. You know, I'm achieving something. I want you to achieve something. I'm growing today. I want you to grow today as well. So I have to do this stuff for you. All right. This one here is our 2-main.c. Let's paste it in first. Cat 2-main.c. Control D. Clear this stuff. And the next thing we want is, what's the prototype? Let's look at it. It's an integer that it's returning, and it's taking in string length underscore recursion, still character pointer s. Okay, still a character pointing to the address of s. Okay, so let's uh, vi main.h first, and okay, the next things first is to build the 2-string length underscore recursion. Let's see. Yeah. So first things first is we are including our main.h file, like I told you guys, and then our function. What was it again? Yeah, I had it copied. Okay. So first things first, especially when we don't want the function to unwind. First things first is we need to account for when it stops. We need to account for when it stops. So if this is the last, if this is the last, sorry, my lecturer is calling me. If this is the last term here, this is a very important call. I may need to take this. Hello, Dr. Teresa. Yeah, good morning, sir. Yes, yeah, it came out yesterday. Yes. Are you in school already? Oh, okay, okay. We'll soon be in school. All right. Thank you, sir. Uh, Sorry about that. I needed to take that. That's from my lecturer. Um, Today is our big day. We have to convocate. All right. Yeah. So, like I said, we want to check for the end term, and that's for when the string is at its last. Oh, remember last time the error we had was it was comparing that as an integer. So we need to put this in single quotes. Okay. So we want to check for the last term, and we want to do a return if it's the last term. So we want to be returning zero here, and then we want to come outside and call the recursive function. Let's return the recursive function as well. Let's return, say, uh 1, remember, plus, I'm going to explain what I'm thinking like right now. 1 plus this whole thing, we want to call the function. Remember what recursions feel like. 1 plus that whole thing. So I just copied it and I pasted it, but I need to come change here, you know, to the current value of x plus 1. Yeah. So this is what recursions feel like. This is us calling the current value of x plus 1. We are incrementing this each time, and then we are just adding 1 to it. The reason we are adding 1 to it, I think you all know, because if we just count it, remember, the first index of s is 0. Okay. So if you want to actually count it and get the first time this thing runs, this would have been 0. So it would have been 0 plus 1, which is 1. So only this would have thrown an error. If it was 12 in total, it would have given us 11. That's why we are adding 1 to it, you know. And this is how we've been incrementing stuff since. Okay. So it's simple, very, very simple. This is us counting the number of characters in this entire string, you know. And like I said, anything you don't understand, you could watch over and over again, and I'm sure that you'll get the hang of it at the end of the day. Did we update our main.h file? Did we do that? Did we do that? Let's cut it. Yes, we have stringlen in here. We have stringlen in here. So GCC then. Ls. So let's do GCC. Are we printing something this time? I don't think we are. And the next one is 2 dash string, right? No, string length. Yeah. And are we using GCC? Are we using underscore putcha? I don't really know. Okay, no errors. So we are not using underscore putcha. Uh, what then do we do? What then do we do? Yeah, we run it. And like you can see, it counted it and it said it's 14 in total. So let's go check. Yeah, that's the return. It's 14. If you want to count manually, You can actually do that, but I don't have that time. This 1, 2, 3, 4, 5, 6, 7, 8, 9. It's supposed to be 14 in total. Okay. Uh yeah. The last one, which I feel like this is where I should take my leave because there's something complicated I need to explain here. It's not even something complicated, it's something I explained last time. I explained the concept of unwinding, you know. I already explained that to you. So let's just go do factorial. Here we might need to put a few returns because I don't think they do factorial for negative numbers. Those of you that are mathematics genius, in secondary school and all that, you would have this information pre-hand that we don't do negative numbers, you know. And then anything zero factorial as well, you know, is all right. Let's copy this main.c file. 3-main.c is what we should call it. Okay, this is the last one we are to be doing here. Cat 3-main.c. Okay, so we have our main.c file. The next thing we should do is update our main.h file, vi main.h. Okay, and we need to go check this n factorial, taking in n again, n int. Okay, we are returning an int, we are taking in int n. Okay, and then the name of the file should be 3-factorial dot c, 3-factorial dot c. All right, let's come paste this here. I'll leave the rest for you to go do. So vi 3-factorial dot c. Yeah. So first things first is bringing in our include our main.c file, main.h file rather. So the next thing is I still have this copied. We build the function. Remember, you guys, your next thing is always to write. Your next thing is always to write a comment that explains what you're doing. So yeah. So for me, like I said, we need a few functionalities. First of all, we need to account for when n is a negative number, like when it's less than 0. And we also need to account for when n is 0. You know, anything 0 factorial is supposed to be 1, and anything less than 0 is we use a negative 1 for it. We return a negative 1. So first of all, we want to know n. We want to do an if statement. We want to say if n is less than 0, right? Let's put this in the bracket. Let's say if n is less than 0, what do we want to do? We want to return a negative 1. All right, we want to return a negative 1. And then we go out of this block of code and say if n is equal to 0. Remember what I said about assignment operators and equality. How many all right, and then if n is equal to 0, we want to return 1, right? So we've successfully handled the hope this is on the same line. Yeah, it's on the same line. So we've successfully handled the cases where we need to return, you know. So we'll keep doing factorial. Remember, this time around, you know, we want to unwind. So we'll return, to unwind, we could actually return the function as well. I've taught you guys unwinding after calling the function, returning after calling the function. We can actually unwind by calling the function as well. So we can return the function as well to unwind. This is me showing you another possibility again. So what do? We want to say, remember, what factorial is the current value of n times that value of n minus 1. That's what factorial is. So if we are to do 5 factorial, we want to say 5 times 5 minus 1, 4. We do the same thing again, times the current value of n, which is 4 minus 1, 3, times the current value of 4, which is 3 now, minus 1 again, 2. So it's now going to be like 5 times 4 times 3 times 2 times 1, that kind of thing. So for each function call, what we are going to do is we want to return, let's return this to make it unwind. Okay. And what do we want to return? We want to say the current value of n times, let's call the function factorial brackets n minus 1, which is the let's make this look good, well formatted. Yeah. So this is what it feels like. We have to double this to close the other bracket. So this is what recursion feels like. This factorial n times all right, I'm going to tell you how this is going to work. So what this does is, let's come down. So let's say we are doing 4 factorial, right? So let's say we are doing 4 factorial. 4, let's say we are doing 4 factorial. We know that 4 factorial is equal to 4 multiplied by 3 multiplied by 2 by 2 multiplied by 1. Yeah, so this is what 4 factorial feels like. 4 multiplied by 3 multiplied, let me use like a calculator to check this stuff. Okay, so this is it. So 4 factorial is like 4 times 3 times 2 times 1. So 4 factorial is 24, right? It's 24. But what this computer is doing, since we are doing it at unwinding, this computer is going to do, for first instance of running this code, is going to do 4 times 3, and is going to still keep the value of 4 times 3 and say, do 3 times 2 and do 2 times 1 and do 1 times 0 as well. And that's where it's going to hit the function where n is 0, and it will return 1. Now the computer is going to multiply all of the outputs together, and from the behind, it's not going to count from the front, it's counting from the back. It's going to add up all the outputs, and it will finally get to the top and see that the total is 24. All right, let's run this and see if we are correct first of all. Are we correct? Are we correct? Do we ls first? Let's see if we have all that we need. So we have 3 factorial and we have main.h, including our factorial function. What else do we need? I don't think we need any other thing. So let's gcc this stuff. Gcc 3-main, 3-factorial, and let's dash o into 3-factorial. Yeah, we are not getting any errors. That's to say that we are correct. Our work is fine. So 3 dash factorial, yeah. So we have 120, we have 3.628 million 800, and we have negative 1. So let's go back and check the what the functions are calling. Yeah, see the return values are 1, 120, 3.628 800, and 1. And that's those were gotten from printing out uh, uh, where are the print statements here? 1 factorial, first of all. 1 factorial is 1 times 1. Very simple. That's why we have 1 at the top. 5 factorial, 120. 10 factorial, this. Then negative 1024 factorial. Remember, we put a function saying anything that is negative, print -1. If it's 0, print 1, return 1. So that's why we've got this stuff here. All right, so I'm going to let you guys go. I'm going to let you to go finish your, let me uh, put myself on the screen. All right. At this point, I have to let you guys go. I have to let you go finish your assignments, and the class is supposed to be 1 hour long. This is exactly 1 hour. For people that are not online, because this is not our time for the class, you all can come watch the video anytime you like. Uh, do have a good rest of the day. Bye.